Hello everyone, I hope you're doing well. So today we will be talking about center tendencies and descriptive statistics. So the first thing I want to go over before we actually dive into the SPSS data and do the homework or problems related to the homework is just how things sort of are put together when it comes to center tendencies and distributions and descriptives. So the first thing is whenever you enter data, it creates a distribution. Now, what is this distribution? Well, it is the spread of your data, and when it is representing the population, this distribution is going to have a symmetrical or an even spread, where you have even amount of information on the right side as in on the left side. And it kind of looks like a bell curve. That's another way of which you can say this is it's a bell curve or a normal distribution. But you just notice how if you split this in half here, you have a mirror image on both sides. Now, typically this doesn't happen when you enter data. You hope it looks like this perfectly symmetrical distribution, but a lot of times data is a little bit asymmetrical, um, not an mirror image as you can see here, but it's not too extreme, so we can still use this data, but it's still not perfect. But there's not really anything that's really perfect. We just want it to be good enough to be an estimation of the population. So in a better way of looking at this, you see all these little data points right here. These are these blue circles. And you see most of the data is in the center. And some of the data is on the right side, which is tail right here, or on the left side, which evens out on the bottom here as a tail. This is the left tail, and this is the right tail. And so this is the perfectly normal distribution, and this is what happens when you get a whole bunch of data, is it has a tendency to have this shape, where most of the information is in the center, and then it kind of gets shallower and shallower as we get more extreme data points on either side. Just so you know, we have this type of notation when we're talking about the sample, which is this lowercase n, and then we have for population is a uppercase n, and that's what represents our sample size if we're referring to a population or sample. And in some cases, maybe we have population information, so we would use the large n rather than the small n. So what happens when our data is not normally distributed? Well, one of the things that happens if your data is not normally distributed is it's not going to represent the population. And there's things that can happen, or there's ways in which it can look like. So this is the most common thing that happens when it's not normally distributed is you have either a positive skew or a negative skew. Remember, a normal distribution is symmetrical, so there's even amounts of information on the right side and on the left side. But in this case, for a positive skew, most information is on the left side, and then a small amount of information is here. So this represents the tail. This is the part that has the least amount of information, and this is the body, which has the great bulk amount of information. And you can see this in this picture right here, where we have a dinosaur, maybe this is a brachiosaurus, and most of him is right here, most of his body is right here, and this would be the body, and then here's the tail, which has the least amount of information. And this is a positive skew because the tail is pointed to the right. Now, if the tail is pointed to the left, the least amount of information right here is in the left, then this would be a negative skew. So most of the information is here in the body, and then there's little information right here on the tail. And as you can see here, the skewness, that's what's called is the skewness. It's going to be negative 1.60. And then if it's a positive skew, it would be positive 1.60. Let's go on to kurtosis. And that really gives you an idea of like the sharpness of your data or your distribution. And when you have a extremely positive kurtosis or +1 or greater, it's going to be, most of the data is going to be right here in the center, and the tails are going to be very, very thin. So everything's going to be right here in the center. And on the opposite side, this is also indication of non-normality, whether it's positive or negative. Negative kurtosis, the data is heavier on the tails, the ends right here. So your distribution is flatter. So that's platykurtotic, and this is leptokurtic. Platykurtic and leptokurtic. And this is mesokurtic, which is a normal distribution where it's evenly distributed and you have a kurtosis of 0. And these are two cases of non-normality, skewness and kurtosis. And this indicates the shape of your distribution. Is your distribution shaped where it is positively skewed, where most information is on the left side and the tail is pointing to the right? Or is the shape of your distribution a negative skew, where most of your information is on the right side and then the tail is on the left side? That is the question. Let's go ahead and move on. So here are some other notations that you'll need to be able to remember, and I would recommend you memorize them because these are things that we're going to use as we move forward. So we have the mean, which is capital M for the sample, but then we can use mu. The symbol right here is mu. Looks kind of like a U with just a line right here. That would be mu for the population mean. And then you have lowercase s for standard deviation, or the sigma, kind of like a 0 with a little line on the top. That's for standard deviation, variance, s squared, and then sigma squared. And as we move forward, I'll go into more examples of what those mean. So let's move on to this idea of central tendency. So one of the first things that we look at when we're looking at our data is we look at the central tendency. So the central tendency is basically one value that defines the best description of the distribution of your data. So it could be captured in the mean, the median, or mode. So when you describe your data, which one data point, which one descriptive, I should say, describes the central tendency of your data best? Let's look at the mean first. The mean is the average of the data set, and how you calculate this is you sum all the numbers and then divide it by the amount of numbers in your data set. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. So this would be n right here. And then this symbol right here means we're going to add each value. We're going to sum each value. And that's what we see here. Once we sum these values, we get 720 over 8. And the mean is 90. Now I should mention, when we have a non-normal distribution, or a distribution in this case that's skewed, this is usually how things kind of play out. If you have a positive skew, the mean is the rightmost value, then the median, and then the mode, and then the opposite is in the negative skew, where the mean is the leftmost value, then it's the median, and then it's the mode. Now, I talked about the mean. Let's talk about the median a little bit. So the median is the midpoint of your distribution. So what is the middle number? So you have a distribution with 50% below and 50% above. And what is that midpoint? And usually when your data is skewed, the median provides you with a better measure of central tendency. Now the mode. The mode is the most frequently occurring score in your distribution. And so let's say you have a series of numbers here, and what you would see here is this would represent the mode, where you have these numbers that are most common, So you'd have two modes in this example. But let's say we have a different example where we have this number, or these series of numbers, I should say. So we have 25, 11, 11, 27, 2, 55, 19. The most frequently occurring number in this data set is 11, so that would be your mode. And this is commonly not used as central tendency. A lot of times your data, if your data is not normally distributed, you would use the medium as your central tendency. And then if you have more or less normally distributed data, you use the mean. But a lot of times people use the mean regardless. It's just a common thing that people report when they're reporting their data. All right, so let's move on. So the next concept we will need to understand is variability. What is variability? Variability means how spread out your data is. And so if you add some dye to water, is most of the dye in the center of the water, or is most of the dye just spread out? So it's spread out. So how spread out is your data represents the variability. And now that's sort of more of a visceral or natural example. Let's look at how it would look like in a somewhat of a normal distribution. So if you have a low variability number, then your data is going to be scrunched up towards the mean, towards the average, and it's not going to be spread out. It's scrunched up right here. But if you have a high variability, it's spread out and it's wider. As you can see here, this is a wider distribution than this one. There are several ways in which you can measure variability. The most basic way is with range, but you can also measure it with standard deviation and variance. With range, what you would do is subtract the highest number. So you have a series of numbers, and what you would do is, if I would use this example right here, sample 2. Let's go back here. I would subtract 100 from 80. That's my highest number. This is my lowest number. And my range would be 20. So in this case, we have a range of 20. And that would give you some indication of variability. But there are better and more precise ways to measure how spread our data is. And here enters standard deviation. Standard deviation gives you an idea how much every data point of your sample varies from the average. So it's a measure of variability by considering the distance between each score and the mean. And it focuses on that distance each score is from the mean. So this is a more precise way of getting information about your data. And now we have another way of measuring your variability. And in this case, what we have here is called variance, which is the average squared differences from the mean. So it's taking this idea of standard deviation and it's squaring it. So it's a measure of variability that uses square units. This does not use square units, the standard deviation. And so this is how you would calculate it. So what we see here is everything here is going to need to be summed up first and squared. So each value